No, times three. I'll wait for 2 more minutes for this to join. Then I'll start.
Okay, sir.
So, hello everyone. I welcome you all for this NPTEL session of finite element method for the January to April 2025 batch. My name is Nikhil Gupta. I'm a research scholar in Department of Civil Engineering in ISC Bangalore. Okay. So this is the lecture for week 5 for this TS session. So I hope you all are watching the lectures on time so that you are getting just of what FEM is and how to solve the problems. Anyone is facing any difficulties with that?
No, sir.
Okay. So what is the purpose of today's class is we'll start solving the solutions of assignment 1 and 2 which you have submitted. We'll quickly recap to those solutions. Since you have the solutions as well, I won't go in depth to them. Then I'll start with the questions which are related to the this week, means related to weighted residuals, related method in this method. Let's start with this class. So this is the question number one for your assignment one. The number of beginners given in each group will produce assignment. So I told you for any bus element There will
I
be,
cannot see the screen. I don't know. Means it's visible to everyone or not.
okay, anyone else facing same?
It's visible to us.
Okay, can you again rejoin and confirm me?
Yes, I will just leave and rejoin. Just a minute.
Okay.
Yes, now it's visible. Thank you.
Okay, let's start this class. So as I have told in the previous classes that in first element, uh, there is always a x-axis, x and force and y force. So always there will be a two nodes in our degree of freedom properties. Then how many numbers of node required to form a coordinated element? So this I have already told you in the class that this is your coordinated element. When it is linear, then 1, 2, 3, 4. And if you have to make each element coordinate, you have to form more nodes. So total now you have 5 and 5, 6, 7, 8. So now answer is 8. So the third question is what will be the size of global stiffness matrix for 2D frame? So since this is not the class, so here you have X force also, you have Y force also, and you also have a rotation thing. Three in each node, so three here, three here, three here, three here, three here, and three here, three here. So answer will be three. So answer will be 21 by 21. So if you have any doubt regarding all this, you can unmute and ask the question. So yeah, in this question, many have told you that the solution is not correct. Yes, let us solve and decide what it is. So it is a direct stiffness matrix. The stiffness matrix to one element given length of and area A and then sum is 2A. So we all know that A matrix one it is AE by L 1 minus 1 minus 1 1. So here in our question, area is A, then the modulus elasticity is 2E and the length is 2L. So this goes to this 1 minus 1 minus 1 1. So this is clearly AE by 1 1 minus 1 minus 1 1. So clearly there is no solution or I think the solution is there. The C is there. This is the solution. So choose the correct option. Quality of convergence of solution gets enhanced with the increase of number of elements. Yes, this is correct. We see more question more options. Second option says quality of convergence of solution gets enhanced with decreased number of nodes. As we know that when they increase the number of elements, the solution increases to and gets closer to the solution. The third option says quality of convergence of solution gets weakened. No, it will not get weakened. We have also seen that answer is so the next question is number of degrees of freedom in mode. So beam element. So beam element, I think the answer is three. Can anyone tell me? The answer is two. I think. How two is the answer? One, two, three will be the answer. If we check what they have given. So, okay, so the answer is two. And can anyone tell me? It is the beam element. So what are these two? Beam of freedom.
Yeah, one moment.
One minute. Yes.
Yeah, another one is in vertical direction.
Okay. What about this X direction? What about
No, we
this?
do not have in beams. We don't consider X load.
So generally, if it is given beam element, you don't have to consider it because it is written down. Consider if written. if consider real deformation also, then degree of freedom is 3. So this is 8 noted action element. So we know it act as a void Q. So it is certainly a trivial. So other question, 8 question number 8 is choose the option which is not true. So elemental stiffness matrix is symmetric. Yes, this is correct. Global square is symmetric. Yes, you know that is correct. Enclosement of boundary condition make global stiffness invertible. This is also imposement of boundary conditions make the global stiffness. Okay, so this is also correct. So your answer is stiffness. One and false. One false. So it is asked that it is not to be. So this is false. And ninth question, what will the global stiffness factors for given bar section area of A in elastic modulus is A. So this is a simple question. We'll just quickly solve it. So for AB, if you have any doubt, you can stop me and ask. So if A of AB will be AE by 2L 1 minus 1 minus 1 1 and K for BC it will be K BC as AE by L 1 minus 1 minus 1 1. When you make a global stiffness matrix K, you will get K of AE by L and zero point 0.5 minus zero point 0.5 0 minus zero point 0.5 minus 1.5 minus 1 0 minus 1 and 1. I think you can do this not directly with this much time. So the answer is D. So question number 10. What will be the dimension of global stiffness vector for a given twist? This is a twist. I told you 2 at every node, 2 to 4 to 6 to 8 to 10. So the matrix will be of 10 plus 2. Now, quickly just cover the solutions of the week two also. So, this potential energy function we have to calculate with the action limit given as P. Similar question we have covered in the previous TA class where distributed load was given. So, I directly write it that potential energy pi is given by strain energy minus work done. So, we know for axial bar, with length L, it is AE by 2 du by dx whole square dx minus work done which is U at L into P. If I have anyone have the doubt on this time, this game, I can tell you, otherwise I can go forward. Okay, so this is the direct formula based question where you have to tell how the functional uniform what is the equation for unit Lagrange equation. So this is directly the formula based question which we can say the answer is A. So question number 3 says choose the correct option. Okay, so to be fully consistent to the linear function, we know that D U V equals to LV. This is not the only linear function. We have a linear function as well. The second statement says stone from physical the system is satisfied mainly at each point of the system. This is correct because whenever the form is found, it is the physical representation of any it is the differential equation of the physical system which is satisfied with each of the values. When we solve it, we get a correct solution. So this option is correct. Then third is weak of the physical system is also satisfied in that each point of the system. So with this we can say that In page 5, it is not satisfied. It is satisfied at the limits only. So this is the question. So this is one. The third which is really this method is the relational method. Give me administration solution. So you all know that it is not administration solution. So answer is 2 and 4 are uh, correct. So answer will be D. So if number says that surface is not there subjected to your of 3.1 in the E and the I are given, and the vertical displacement is given. We will be given this is equation of the so we all know this is a Euler Bernoulli equation in B. We know that this is the option value C. If number 5 is equal to B is subjected to UDL, length is this and A is given. We have to get the same question, we have to find the number of boundary conditions given. So as we know, number of given in the higher order differential equation is the number of boundary conditions we require. It is 4. Okay. So the question number 6 says simplicity of B is subjected to UDL. So the same question is there. Now we have to find a wave parameter which is B into A. So when you solve it, you will get the solution which is A prime. This is the genuine weak form solution of the uniformity wave. Number 7 is saying that education function is given. You have to find the wave function V is given as V. By linear and linear function, active integration by parts will be. So I have shown what many questions we can do this. And if you have anything, you can stop here. Otherwise, I'll directly give you the answers there.
I have one question here.
Okay,
Actually,
please.
when I was solving the question,
Yeah,
the bilinear part is correct, but the linear part there will one extra term is coming, that is minus v into du dx at x equals to 0.
at x is equal to 0,
No, it's
uh,
given as one. It's not given actually, so it should be there in the linear term. V into
okay,
1 minus v into du dx at x equals to 0.
x is equal to 0, it is not there.
Up to v into 1 is coming.
Okay, which one is coming? And
No, d is correct, but in the linear term,
okay,
integration 0 to 1 vx cube dx plus v1 in
plus
minus v into du dx at x equals to 0. That should also come as per my calculations.
is anyone else also getting same? Okay,
No, I didn't get it.
I don't think we get it here. X is equal to 1, x is equal to 1. Let's see it. So when you solve it, you will get 0 to 1 b is d2u by dx square plus u square plus x cube dx is equal to 0. So this we are solving the residual. And when we apply our value to integral by parts, what we will get? We will get b is this. And when you differentiate it, you will get du by dx at x is equal to 1 and at x is equal to 0.
This term I was saying.
Okay, now you are saying okay, it should so the it will be generated by uh, this- yes, it is going to be 1.1 of this. This is Okay, I'll see this later. And let you know anyone knows then tell me also. The next says choose the option which is not directly differentiating maybe higher order two. So this is the boundary condition which is negative field variable. So here the in this line says that f is given. The numerator Euler Lagrangian equation will be so in that way we get this by dy by df by dy by dx df by dy minus 0 means you will solve it will actually get this solution. So question number 10 is you have to choose the correct option in the following statement. First statement says some form of a physical system is written in one-dimensional. That is true. We have seen that every physical system which you are solving using the potential energy and the unidimensional equation, we are getting the potential equation of it. The second statement is saying that we think it is only anything, even if it is not known, it is not correct. The third statement is whether this method is a very simple method, giving approximate solution, which is also correct. So one and three are the correct options. This is B. We have covered the solutions of the core assignments and going into the problem which we have placed in the question and post up in the main box. Now let's start with the questions which are related to this study. So this is the questions I have to take. Just go to it, put your place in the So in this week, you have learned about different weighted residuals method. Now, the questions are related to it. The first question which I have prepared is this. There's a like a differential equation of a system, which is E is to F. A is the operator in differential equation. And phi and V are the approximate and the weighted function. Then you have to choose the correct option. So this is generally, we know that in case of example, uh, or we know the things there, we know likely where we is simplify. In other methods, it is not there. So the answer is C. Or just let's solve some uh, more question. This is the question number two. Where a differential equation is given and the boundary condition is also given. What you have to do, you have to consider U as a one parameter approximation. With U bar, U part is given. Plus guidance is also given. Guidance is also given. You have to select it throughout the mapping method. Just have a look and then so let's start this question. Let's first write what it is given. On the data, f is given as c1, i1 plus i1. Where phi 1 is mentioned as x 1 minus x and phi naught is mentioned as 1 minus x. So you have to find the you have to find the coefficient of C1 with graphing method. So we know that while solving that, we need to solve this r dx is equal to 0 means the residue we have to solve with the weighted function as v. This integration into 0 and its condition is 1 0 to the 9. Ultimately, we have to solve this to get the coefficient C1 for this weighted function. So it's first find the residual. So what residual will be? Residual will be 3 d2u by dx square plus 5. This will be the residual. I have made this let's right here. You can find the residual thing. Put the value of C is very nice finding. We will get it as 3 d2 by dx square is C1 phi 1 plus phi n plus 5. So let's put the value of phi 1 and phi n as well. D2 x d2 by d2 x square C1 x 1 minus x plus 1 minus x plus 5. When you do a current differentiation of this one, this is actually written as this is x minus x square. So when you do a differentiation, this will be 1, then it will go to 0. When you do a double differentiation of this, you will get minus 2, and then you will get 2x, then again you will get minus 2. For this, you will get 0. For this dimension, you will get 0. So you solve this, you will get 3 of minus 2 C1 minus minus 3 of C1 uh, minus 2 essentially minus 2 in this, so 3 into 4 uh, C1 with plus 5. Okay, yeah, plus 5 it will be. Okay, so when you solve it, you will, this is basically you have done, right? When you will so by a graphing method, you have to solve this as V R dx into 0. V will be the x 1 minus x, and this is x p1 plus 5 plus 5. There will be positive, this will be minus 2, minus 2. Okay, so when you will solve this, you have to solve this with I, which is minus 6 C1 plus 5 dx. So this part is constant, we can take it out and we have to solve it as 1 x minus x square dx. We solve it using x square to 4 x cubed by 3 0 to 1. This is 1 by 2 minus 1 by 3, which is 1 by 6. Okay, so you will solve this. You will this will be 6 C1 plus 5 into 1 by 6 equal to 0. It was already there. So when you will solve this, you will get minus C1 plus 5 by 6 So C1 is equal to 5 minus 6. We will save that means not one back into some weighted distribution method using mapping method. This
So,
one thing that
how do we took the value of v as x into 1
we,
one x?
we use always the this x minus this 5 1. And this method
Okay,
we
it's
are using
phi 1 for Galerkin method.
mapping method. Yes, mapping method. Okay. So let's see the question number 8 plus only. We can question then which is the next method. You just have to find the residual of this. Well, this is the one of the part that we have solved in the second question. Now you all know how to solve the residual of any differential equation. We can out here as well. So in this question, residual will be d2u by dx square plus 5u minus 2x. Okay. Now, first we have to put the values which are given. Given stuff c1, phi 1 plus phi naught, and phi naught is given as 1 minus x. Phi 1 is given as x 1 minus 2. Okay. So we can put it in the value of r, which will be r equals to d2u by dx square plus 5u minus 2x. The same thing I will get. Next one, so we c1 uh, d2 phi 1 by dx square. Or just let's substitute first d2 by dx square, and this u is given as even phi 1 plus phi naught plus phi even phi 1 plus phi 2 plus 2x. So without let's do one more step before substitution. C1 or we can write directly as c1 d2 phi 1 by dx square plus d2 phi naught by dx square plus 5c1 phi 1 plus phi naught plus 2x. Okay. Let us get the value of d2 phi naught and d2 phi 1. Let's do it here. So d phi naught by dx is minus 1 and d2 phi by d phi naught by dx 2 is equal to 0. Then if you write d phi by d phi 1 by dx, which will be 1 minus 2x, and d2 phi 1 by dx square will be minus 2. Okay, so these value will be using there. So d phi 1 we have seen it is minus 2 c1. Okay, phi naught is 0. It's 5 c1. Now no differentiation, we have to directly use phi 1, which is x1 minus x. So we can write x minus x square plus 5 of phi naught measures, which is 1 minus x. 1 minus x plus 2x. This is minus 2c1 plus 5c1x minus 5c1x square plus 5 minus 5x plus 2x. When you will solve it, you will get, let's take c1 common. So this will be minus 5 square, then plus 5x minus 2, minus of minus 3x. Sorry. This is minus 5 so it will come here minus 2x, then minus 2x, then minus 2x, and this one is 7x. Uh, and the plus 5 as well. So this is the solution. When you see our residual in this, you will see the answer is B. You find given all steps, didn't really continue. Other questions I think are related. Question 3 to 9, which another question it says, suppose we are the weight function and residual respectively for the system. What is the correct function for rapid residual system and least square method? Okay, so we have to solve this by least square method. Anyone will remember how to write how to write the weight function in least square method. Anyone, just a random guess also is okay.
Yes. That is square d of the region.
Correct. So what is the formula for this is del I by del constant, let's say it is C1 here, then into R into dx is equal to 0. The limit is mainly 0 to 1. And this is the formula which will go for next square method to solve the method decision method. Okay. So since it is the continuation, we can use the R value from this equation. And we have seen that this we have got this R value. Okay, so start with this as well. R we can write directly here. C1 minus 5 6 square plus 5x minus 2 minus 7x plus 1. Okay, this R. Let's calculate dr by dc1, which is equals to minus 5x square plus 5x minus 2. Okay, so we don't need to solve that in this question. Just we have to write the statement. So what will be the statement? It will be 0 to 1 minus 5x square plus 5x minus 2. Then r is the same. We can write r as well like this. And this is the question goes back to 5x square. And the solution is 8. Yes, 8 and that's the solution. This So, because what is the value of information saving of this also okay. Since it is in continuation, now you have to solve this equation with the next time bracket to find the value of C1. Solve the link. So, what equation we have got is right here 0 to 1 minus 5x uh, square plus 5x minus 4. Which will r dx equal to 0. Let me solve this. Let's R as well. What you are getting, we can do it. Is it fine?
Yes.
Okay. 0 to 1 minus 5x square plus 5x minus 2. And if we write this, the substitute R as well, we will get minus 5x square plus 5x minus 2. Then we were having minus 7x plus 5 as well. This whole dx we have to solve and make it 0. Get C1. Okay, let's do one thing. Let's divide into two parts. Let's solve this and this. So, since this we can say is the same term, these two are same terms. What we can write here minus 5x plus 5x minus 2 minus 5x square plus 5x minus 2 to save 0 to 1 dx. Okay, I'm solving this manually and we'll add it. Let's multiply it with 5x out 1. We can do a whole square as well. Whole minus this 25x cube. Then we'll get plus nx square minus 25 cube. Then again 25x square minus nx plus nx square minus x nx. So okay, so just like extension of this term, it's not anything else. Just multiply the two terms. Uh, then the integration 0 to 1 with t1 dx is equal to 0 to 1 dx. So this we have to do a integration here. This will be 5 small 5 minus 25 by 2 x power 4 plus 15 x cubed minus 10. Wait, we should write one more step here. It is coming with as 25 x power 4 and this will be minus 50 x cubed. X cubed is x cubed. X cubed 50 of the x square will come as 5 55 plus 45 x square minus 20x plus 4. Now we can integrate this with even dx. We integrate and then divide by integrated results. This 5x cube 5 minus 25 by 2 of 4 plus 15x cube minus 10x square plus 4x from 0 to 1. So 5 minus 25 by 2 plus 15 minus 10 plus 4. You solve it. This is minus 25 by 2 plus 40. This is this minus 14. With 14. You solve it, you get 2 plus 25 plus 28 here. You will get plus 3 by 2. Okay. Now this is the first part of the integration. Another part is very simple. This is minus 7x plus 5 dx from 0 to 1. And this will be, we confirm the equation. Yes, minus 7x plus 5 is correct. We'll solve it. We'll get minus 7x square by 2 plus 5x from 0 to 1. Minus 7 by 2 plus 5. 2 minus 7 plus 10 is equal to this Okay, this equation will be multiplied by this vector residual force. This will multiply by this and then we get the second time, which is minus 5x plus 5x minus 2 multiplied by minus 7x plus 5 dx will 0. Okay, is it really like that? This term is multiplied by, so this will be like this. Okay, so now we have to solve this as well. So this will be 55 x cube, uh, then 5 cube, 35 x cube, then minus of 25 x square, 35 x square, 25 x, then plus 14x minus 10. If you check it, it's fine. So plus 35 x cube, uh, 15 minus 25 x square, then 35 x square, 25x minus plus 14x minus 10. Okay. Mm, this is 0 to 1 dx. You solve this with 55 x cube, then this 25 goes to 55 x square is very common. X square 3 x square. So this is x square. So this will be 60x square plus this 39x. You see a mistake, you can directly unmute and remove it. Okay, this looks fine. Now let's integrate it. So we get 35 by 4 power 4 minus of 20x cube plus 39 x square by 2 minus 10x. Integrate from 0 to 1. Directly write the after putting the solution. It will be 55 by 4, then minus 20 plus 59 by 2 minus 10. Okay, so when you solve, you will get to 4 as this, and 55 plus you got 78 as double, and 20 will go, 120 will go. So this is correct. Okay, so when you solve this, will be 35 plus 28 minus 120 is minus 7. Now we have solved the equation into two parts and then we have solved it. So the first part result was okay, C1 will be there, C1 will be there, C1 will be there, this will be C1. It will come out with 3 by 2 C1 minus 7 by 4 equals to 0. I hope you are getting what it is. So 3 by 2 C1 equals to 7 by 4. So um, something is coming out. So C1 is 7 by 6. If you go to let's see the answer in this. Let's just see. Was some mistake happened to have this clear now. You can be done. I hope it is clear. Okay. So now you have to write the equation in the unity which you have assumed. So what you have assumed initially is the problem is so you have assumed that 751 plus y naught. We use to C151 plus y naught. Now C1 we have as 7 by 6 and y naught is also we know. So y is x 1 minus x and y naught is 1 minus x. You will solve it, you will get 7 by 6 x minus 7 by 7x square by 6 plus 1 minus x. X 7x minus 7x square plus 6 minus xx. This is minus so if you want to solve it, the options are like that. You can directly write this answer. So this answer is matching I think B part. This A is I think you don't need to solve. Otherwise you can solve and get the solution as well. Okay, let me ask you one question. Uh, it will be that the least square solution with paper which you as this. Uh, let me say that you have L variable as this. Now there are two variables, C1 and C2. Tell me, solution, anyone, you have to solve this equation, solve this problem using this square method. I'm asking you the equation you will use for this weighted residual method for following this. So the question which we have solved earlier is, have you seen we have CPUs also there? You want to unmute and give the answer? Give it try anyway. We'll wait for 2 minutes. Okay. What else? You can even write if you want. It's very simple. So what you will have, since you know here two unknowns are there, so you will have an extra equation as del R by del C2 or dx is equal to 0. what you will get here, you will get an equation in terms of C1, C2 here. You will get equation C1, C2 here, and two variables, two and unknowns. So you can solve and get C1, C2. I'm not sure you can ask me now. You can ask.
Hello.
Oh, yeah,
Am I
tell me.
audible?
Very,
Yeah, I have some. Yeah, I have some basic doubts actually, not
hmm,
actually related to this thing.
okay,
Uh, yeah, it is about the potential energy density equation we have written in the very beginning.
okay.
While we derive this element, this
Different vectors.
calculus of variation.
Okay.
So yeah, so there we write this equation like strain energy minus the external work done.
Yes, yes.
So, yeah, can you actually the issue is like whatever work done we do on the system that is stored
Uh,
in the form of strain energy.
yes.
So, so one thing is like if that thing will only give us equal to zero. Why that is equal to potential energy? Like external work that like the strain energy minus work done
Okay.
should be equals to zero,
Minus
but it is
C.
equals to potential energy.
Well done. Okay. So
Yeah.
work done is external. Strain energy is the internal energy which is stored. Uh,
Now, this internal energy stored, that is only the potential energy. I mean to say that strain energy
oh,
itself is the potential energy.
no, no. Potential energy and strain energy are different things.
No,
Oh,
the potential energy has two, like one type of potential energy is in the form
yes,
of elastic nature,
yes,
and the
that's
strain
actually.
energy gives the same thing. Yeah, that strain energy will give the same thing. So it is kind of potential energy.
Uh, explain you this. Go to it to tell you the answer. Not to explain you this. Mm, no, okay. I'll think a little bit. I'm not getting the answer to it right now.
Okay.
Mm,
So can I ask another doubt?
tell me.
Yeah. The next is about the same register current problem. Like, but not exactly about register current.
Which one?
Actually, the problem is the register current problem we
Acha, acha,
discussed.
this one which we like this.
Yeah.
In,
So there we take this y tilde is equals to y plus epsilon eta. Can you
uh,
write it? Yeah.
y
Y tilde.
tilde, you write something like this. Tell me again.
Y tilde is equals to y plus epsilon eta.
Epsilon eta.
Okay. Y
Uh,
tilde I guess not yt.
tilde, na, I don't
Okay.
know.
Okay. Okay. You can write it.
Hello, huh?
Uh, yeah. So here actually I don't understand. There is like one thing is this eta is arbitrary curve which is
Yes,
going ahead
arbitrary,
by
yes.
y.
Uh,
Yeah, and
uh,
epsilon we take
yes,
anything some scalar value,
scalar
right?
value.
So like, but I don't understand that this thing that when this scalar gets multiplied by this eta,
Mm,
which is an arbitrary curve, it is
uh,
going to give us different kind of curve,
they will give you
right?
different
Different
curves. Yes.
families.
Mm,
Yeah, but from eta there are multiple curves that could be possible. Not only
uh,
is getting a multiplication by eta will give us this thing. So why we choose this only specifically this equation like eta x.
So theta is not is not defined here. It's a scalar value that changes the value of the two. So like this also, like this also. So for that,
Hmm.
we are using a scalar value so that we can change the value of the curve.
That I understand, but
Uh,
we have chosen eta. Let's say
uh,
it definitely it is arbitrary, but it has
yes,
something like equation.
yes, yes, yes.
Okay.
Mm,
Now we multiply it with different epsilons,
yes, yes,
some scalar values, some
yes.
so how can we get these different curve just by multiplying? Like let's say eta arbitrary is something like it's very simple, some ax plus by
Mm,
or something b
okay.
something. Now I multiply it by 2, then I multiply it by 3. Will I am I I'm not going to get this kind of curve then. That is why.
One more thing that we have to satisfy the boundary conditions here.
Well, that is satisfied,
Ah,
but
so
once.
when you satisfy the value condition, you when you multiply the scalar value, it will get
Hmm.
change the standard point. You can reach it by like this also, you can reach it by like this also.
Okay. Can you demonstrate it by some equation? Like,
Uh,
because thinking it like this in this way is very difficult.
see if I might know that to figure it out. But that's what I tell you. Let's say we
Hmm.
have y as this, and for every eta value, since we are keeping this boundary condition as same, what you will get whenever you change eta, you will get a different curve. So we are optimizing this curve to get a this perfect solution.
I
For
okay.
example, I don't have it right now, but
Okay. Let me
uh,
tell.
uh,
Okay. Let us think in this way.
uh,
The most above the topmost curve what you have made.
okay.
Let's say equation is ax square plus bx plus c,
Uh,
and the boundary condition is fixed that x
uh,
at x equals to 0 and x equals to let's say l or something.
okay. Yes.
That value of it is fixed.
Uh,
Yeah, at
uh,
this point, let's say this
okay.
value is going to
Let's
come.
see.
Now, if yeah, now my question is now if I just multiply it by some scalar value, will
Uh,
like this is very difficult to digest that how I am going to get
so
such kind of curve.
let us multiply this value with 2. Let's take a equation as x square.
Hmm.
Let us take like this. Okay,
Hmm.
y is
Hmm.
equal to x square. Now, if we take as 2x square, oh, to multiply it with some scalar value, uh, mm, uh, I'll find the example related to it. I'll go to the theory of it and post
And
in the you can ask for.
yeah, the last thing,
Uh,
also third thing, like
uh,
once we have, let's say it's the equation is okay, this
mm,
y tilde is equals to something.
uh,
Why we are taking the differential like in epsilon by like we need to fix like d. Why won't we take this d y tilde by dx or d eta?
no, you
Why
are
we only
changing
keep.
epsilon. You are changing epsilon in each of the equation to get a different path.
Yeah, that's
Uh,
okay. Yeah, that I thought, but
uh,
eta we have to fix in that way. Okay, so first thing is like whatever the choice of eta,
uh,
it might be arbitrary, but we have to fix it. Then
uh,
also, then only we can take in the form of eta. Like then also, then only we can take the differential with respect to epsilon, right? The second thing is like, but x is still variable.
it's still variable. Yes, it's not x depends on
Yeah,
the it's not the variables you are giving.
yeah, but it is still variable.
X is
Like
still a variable. Yes.
it is very difficult. Like now, how we can take the partial differential in the form of epsilon when there we have two things which are varying. X is also varying, and eta epsilon is also varying. Eta we can fix definitely.
So now you are not doing a driving. You are solving the kind of full problem. You are taking the derivative of this full term
Full
and
curve.
solving and how you take let's say there are two guys. This is one term. This is one term.
Hmm.
Now x is variable. But you are
Hmm.
getting you are changing epsilon. So
Yeah.
since you are doing a differentiation in this epsilon, so you are varying that this time is okay, this time is okay, or this time is okay.
Okay, yeah, that
Uh,
is what I'm going to come on,
uh,
come on this point only. Now, okay, so we are only varying these curves, but
mm,
how this all our differential formulas and the
uh,
Taylor series is valid for such things also, because we see the derivation of such
uh,
things like
uh,
differential formulas or partial or whatever Taylor series what we are going to use
okay.
afterward.
Uh,
Those all are valid for functions
they are working.
where we have given an input, a variable input is
Mm,
given like x or y or something, but here we are giving input a function itself. Then
we
how
are
we
giving
can
a
prove it?
differentiation.
Yeah, yeah, then how we can put, how we can like say that it is also true for these things? Like what is the proof for like how this is true for this when we are giving function as an input?
So you are saying telling what is the proof for a Taylor series expansion of the function.
Yeah, kind of, you can say,
Uh,
because there we drive it for when we are giving a variable. Now
uh,
we are giving input as a function.
we are going as a function, yes.
Yeah, and we are using for differentiation, for
Mm,
Taylor series, everything we are using same formulas for differentiation also,
yes,
like
we
taking the
use
total differential, we take sum of partial differential, everything is same.
yes.
So how we come to this conclusion that is going to be same?
Okay, but it's mathematical proof, so I don't have it right now. Means I even internet thought of it like this. Oh, I can't explain you right now about that.
Okay.
Uh,
Okay, so these are the three things actually. If you find it, it
okay.
will be great.
Uh,
They
okay.
like the first thing about the potential energy. The second
Uh,
is about why
I have written it,
delta.
no problem.
Yeah, yeah.
First of all, I'll write in the community guidelines, the Google forum.
Okay.
You can with the material also.
Okay.
Uh,
Okay. Okay. Thank you. Okay.
okay. Yeah.
You can continue. Thank you.
Uh,
But Sivank, I have one addition to the first question. I was thinking about it, that the potential energy we are speaking through the strain energy thing is we are only talking about the strain, the elastic one, elastic potential energy. When we are talking about strain energy is stored as the work done. But since we only driving for the say displaced body, so there is a deformation and the energy is stored in place of that deformation. But there are other energies as well, the potential energy. This is the total potential energy in the equation. When we write the potential energy is strain energy minus work done. So it should never be zero in that case, because other energy, say gravitational potential energy, is also there. But this
But
is just
even if, yeah,
I was
sorry to
just
interrupt you.
thinking. I have no mathematical proof right now, but I was just thinking that it should
And
not be
I,
zero.
yeah, and I personally think that actually it is the complete work done is not going to get stored in the form of strain energy, but other energy we can neglect. Even if we neglect other energies, what you're talking about, even then this
Hmm.
equation is valid. It is not going to be get zero because all the external work done is
Yeah,
not
it
going
should
to
be a
get
general
stored in
equation
there.
in that case. Yes,
Yeah,
I
that
think
is
so.
this, but there is no written thing. This is just our
Yes,
intuitions,
yes, yes.
but I don't find any literature behind it that why this energy is equals to potential energy. Yeah,
Mm. Yeah, there should be some literature, definitely.
mm,
Maybe I don't know, and you don't know.
yeah.
Okay.
okay. Let's continue with the questions. So we'll continue the same question. Here we have to use the collocation method. So we have to solve it by this. Yeah. So, uh, so the question says, suppose collocation method is present to obtain one isolation solution for you, which is this. What is the expression for you? Seven collocation point to expression point five. Okay. So what we have to do? We are using a same question. So we can use the same recipe, which was which is C1 minus 5x square plus 5x minus 2. C1 is written. Then minus 7x plus 5. Okay. So since it is saying that collocation you have to find at point 5, we'll put like this. So let's see what we get. We'll get C minus 5 1 by 4 plus 5 1 by 2 minus 2, then minus 7 by 2 plus 5. So collection should be equals to 0. We solve this, we get minus 5 by 4 plus 5 by 2 minus 2 C1 minus 7 plus 10 by 2 equals to 0. We solve this, same as 4 minus 5 plus 10 minus 8 C1 plus C by 2 equals to 0. So it becomes as minus 3 by 4 C1 equals to 3 by 2 minus C1 equals to 2. So when you will put this in loop, you will get minus 2x square plus x plus 2. So the solution will be the A part. Okay, now you have to use the new Clarkin method to find the coefficient for the same question. Yeah, let's solve this now. So with Martin, you know that you can use it 5n as the one. So let's begin with that. So we'll use the same part residual and M5 this will be minus 5x square plus 5x minus 2 this C1 minus 7x plus 5 dx is equal to 0. Okay. So the next one is so let me see for beginning Latin method. So let's start solving it. So multiply it, we'll get minus 5x cube plus 5x square minus 2x C1 minus 7x square plus 5x plus 5x power 4. Then we'll get minus 5x cube plus 2x square of C1. Okay, then plus 7x cube minus 5x square dx is equal to 0. Okay, let's just take C1 as common. What we'll get minus 5x cube plus 5x square minus 2x plus 5x power 4 minus 5x cube plus 2x square. Uh, okay, then minus 7x square plus 5x plus 7x cube minus 5x square. Uh, then this is also dx equal to 0 with 0 to 1. Now let's see if we get the value. We'll get uh, uh, students 20 this is 5x, so it will be 7 minus, before integrating, let us make it more precise. Is 5x power 4 minus 10x cube plus 7x square minus 2x plus 7x cube minus 12x square plus 5x dx equals to 0. Now let's integrate x power 5, 1, 5, no, pick up x power 5 minus 5x power 4 by 2 plus 7x cubed by 3 minus x square of 0 to 1 with C1 plus 7x power 4 by 4. Sure, you can leave the program. Minus 4x cubed plus 5x square by 4 from 0 to 1. And you put the uh, limits. We get 2 minus 1 by 2 plus 1 by 3 minus 1 C1 plus 1 minus 4 minus 4 plus 5 by 4 also 0 minus 3 plus 4 plus 6 C1 plus 7 minus 16 plus 10 by 4 equals to 0. When we solve it, we'll get 1 by 6 C1 plus 1 by 4 equals to 0. And this will give you a C1 as 1.5. So we just have to find this constant C, which is C1 is 1.5. So this is the last question of this the series we are solving for this. So you just have to get the P value. And since you have the value as 1.5 C1, so you will get 1.5 x square plus 0.5 x. Answer will be B. Now let's solve one more question. Yes. Let's see. Cantilever step bar, which is made of two different materials, M1, M2. The bar is subjected to action load of technology. This end and E1 is given, F2 is given, properties is given, and you have to find the displacement at node 3. So, start with the question. So, this is something this three nodes are there. Let us take this is as 1, this is as 2. So, when you write the given matrix, this will be AE by N 1 minus 1 minus 1 1. Okay, since it is it will be like this. So, quickly go to the global stiffness matrix. We have seen many times how yes, element square matrix is related to global stiffness matrix. This is A1 E1 by L1 minus A1 E1 by L1 and 0 is minus A1 E1 by L1 and positive of A1 E1 plus L by L1 plus A2 by L2 as this node is common in both. Then it will be A2 by L2 of minus A2 by L2. Here it will be minus A2 by L2 and here it will be 0. When you substitute the value, uh, you will get the K matrix as 198 4 times 0 and minus 78 4 times 0 then 78 1 2 3 4 and 78 4 9 10. Clearly see it is symmetric with a symmetric matrix. And while solving, you need to solve KU is equal to you need to solve KU is equal to F. So this F matrix what it will be? It will be F1 plus F2 and F2. So we shall see the question. F1 is unknown, F2 is 0, and F2 and this is known. So this is having at 1, F2 at 1, F2 at 2, F2 at it should not know. You should write it F1 at 1, F2 at 1, F1 at 2, F2 at 2. Okay. Now this is unknown. This F1 dash is unknown. 1 is unknown. F2 dash is 0. F2 is 0. This is 0. And this is known. So what you can write here is this is equals to F1 dash is 1 and 0. Then the value it is very 50 kilometers. So we can write like this. So you solve this, you will get a KU is equal to F as 1981234 minus 781234 781234 78 from U is into 2 and U3 and this will be 0 and 5 2 3. So you have to invert the matrix and when you will solve it, the U2 U3 what you will get will be equals to 0.0119 and 0.0763. So you can see the answer is D. Okay. Now let's solve this question. Note this question. You can see the question is given like this. Let's solve it. You have to use the correlation method. So what we can write part with d of 2 plus x by
In
dx.
the last question,
Yes,
uh, from kg to k, this k is k unknown, no?
which is
What we
unknown.
have written. Uh, this global stiffness matrix is 3 by 3.
3 by 3,
Thereafter,
yes.
thereafter we have written a 2 by 2
Okay,
matrix.
it got
So
so
this is a partitioned matrix, right?
this will
Mm.
be this will be U1, U2, U3.
Okay, okay. So you have partitioned the known one.
Means this will be no matrix, this will be matrix. So for this one
Hmm.
here, you will have to reduce this and then use this.
Okay, so known and unknown parts we have divided.
We are removed. So U2, U3 are unknown, and here F2 is known, F3 is known.
So only two and third one is active. For one
Active,
is
yes.
gone.
Uh,
Okay.
so if you use again this U2, U3, you can get this happening as well.
Yes, yes, got it. That is.
Uh, So in solving this, we're using this and du by dx plus 2 plus x d2 u by dx square minus u is equal to 0. What I have done, I have used uh, yeah, multiplication rule because it looks like it is like this. Okay, so now this is an equation. So would be it becomes now you can see if you differentiate this, this will go to 0. This will go 0 because 2 is 1. I mean, it's equal to 1, not 0. This is equal to 1. Now you can write your equation as du by dx plus 2 plus x d2 u by dx square minus u equals to 0. It is equal to 3. Okay. So since you have to form the allocation method, you have to find the mean. So let's write r as du by dx plus 2 plus x d2u by dx square minus u minus 3. So this will be your residual. Now let's put the value of u, which is this will seem like a nice question. You will get d by of dx e1 phi 1 plus phi naught plus 2 plus x d2 by dx square c1 phi 1 plus phi naught minus c1 phi 1 minus phi naught minus 3. I've just put the values in u. So when you start solving it, you will get d by dx of c1 x minus x square plus x plus 2 plus x d2 dx square of c1 x minus x square plus x minus c1 x minus x square minus x minus 3. Okay, so when you will solve the differentiation, you will get c1 1 minus 2x plus 1 plus 2 plus x minus 2c1 minus c1 x minus x square minus x minus 3. Okay, now this equals to c1 minus 2x c1 plus 1 minus 4 c1 minus 2x c1 minus c1x plus c1x square minus x minus 3. Okay, so I'll skip a step and write the final version as c1 x square minus 5x minus 3 minus x minus 2. Okay, so first, since we have to use our multiplication method, we know that at u0 is given as 0, at u1 it is given as 1. Let's take a calculation at 1.2, uh, which is we will put it, we get c1 1 by 4 minus 5 by 2 minus 3 minus 1 by 2 minus 2. We'll solve it, you will get c1 minus 10 minus 12 by 4 minus 5 by 2 equals to 0. We'll solve it, you will get a c1 as minus 10 by 21. Okay. it's now we are asking approximate solution, so you have to apply this in U as well. When you write U equals to U is equal to C1 by 1 plus y naught become minus 10 by 21 of x plus 10 by 21 of x square plus x. In points, when you get it, uh, solve it, you will get 10 by 21 of x square plus 11x by 21. This will be 0.476 x square plus 0.524 x. So there's when you use question, you will get the solution is this if you solve the question using this method. Do this right. But so you will not get any of the result. So this suggests that the equation here it should be 2 plus x and d2u by dx square and minus cu equals to 3 and you will get a solution with this. So I just want to show you that this way also we can, if this is also the equation, we can solve it also. But the questions, the options will not be matching because options are prepared assuming this. Okay,
Sir,
so
I have
let
one question here. So we used collocation point as 1 by 2.
1 by 2, yeah.
So why
But
have we used this?
but
Means
the
it would have,
same thing is collocation point is not given. So
yes.
if it is not given, we are saying that at 0 it is defined, at 1 it is defined. So
Mm-hmm.
it's best just to take the middle point and solve it.
So, but how do we know that the residual should be 0 there?
So that's what, yeah, we can't say here to be 0, here to be 0. So
Mm,
we are assuming that at the midpoint is the safest point, take it as a 0.
okay.
Uh, Otherwise, they have to give you the collocation point as well. Maybe
Yeah, that is
the
what I'm
collocation,
saying. In
huh,
MCQ type questions means
uh,
if it's someone takes a different collocation point, then it
it
is
will
also
be
the correct method.
uh, it is also a correct
So,
pattern, but that's what in question it should be given. Or else, if you are assuming, you have to assume a midpoint so that the
mm,
assumption is you can give a proof. You can give a valid reason.
yeah, okay.
So now this is a different question I've brought. So there are two physical problems which are Given here, one is known as non-linear equation and other is beam elastic condition. You have to construct a weak form of it, and if possible, you have to get the quadratic function as well. So let's start with this first one, which is a non-linear equation. So let's begin. The equation which is given as the a point minus a d by uh, dx of u du by dx plus f equals to 0. So it is given from 0 to 1, and these two equations are given. Now let's form a weak form. Maybe you will get 0 to 1 w is the given function minus w d by dx u du by dx plus f dx equals to 0. Okay. Now we'll solve this um, 0 to 1 w say my d by dx u of du by dx is dx plus separate it. Okay. So let's apply my parts here. So what do we have is the minus w du du by dx from 0 to 1 plus 0 to 1 dw by dx of du by dx plus 0 to 1 w of dx equal to 0. Yeah. So now boundary condition method is given, it is given as u1 equals to a root 2 and for me to this quantity part w1 to satisfied equal to 0. Okay, so remember what the solution for the person asking the question related to that is here for the question. We form question was there. This one is the person who asked the question is here.
Yes, yes, yes.
So it should if you are given the boundary condition at v equal to 1 is 0, that the v1 should be 0. Means it should satisfy the homogeneous continuous. So if u0 is 0 is given, then
Mhm.
v0 should be given. Like in this question I'm telling you, see, it is given by u1 as this. So its homogeneous counterpart will be w1.
Okay,
Okay, and it should satisfy 0.
okay.
So when you have reading the literature, to that in the lecture that we assume the next lecture, it should satisfy the homogeneous counterpart of the condition. Understood?
Yes.
You remember
So,
this?
but if yeah, I do remember it now.
Uh,
But let's check my solution. Okay.
U0 is given, so you have to put W0 also as 0.
No, but in this question, what I was saying was du by dx at x equals to 0 was coming. Oh, no, 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 no,
In
no,
this
no, no,
question,
no. No, no, just
I'm
let me
moving
check.
that question
Maybe
as
I
well.
think I got the wrong one. Yeah, du by dx at x equals to 0 was coming.
Okay, so du by du, it is given, na? Uh,
No, du by dx at x equals to 0 is not given.
no, it is given, na? So this part is okay. Means
Yes, this part is fine. Yes,
this part is fine. You are worrying about this now. So
yes,
here
yes.
you are getting V0.
V into 0 du by dx at
V
x equals to
du
0 is given.
you are
It's not
getting
given.
V du by dx at x equal to 0.
Yeah. So how this is becoming 0?
Yeah,
The homogeneous counterpart is is
that
v
should be
dv dx.
that should be V by dx. Ah, okay. Okay. What it is like that.
Yeah.
Okay, so it is like that, and it is also given that du by dx x is equal to 0. So these things are there. You apply this in this way, you will get value from as 0 because du by dx is 0. Mhm. Okay, okay, u1 is 2. and you will apply this, you will get new form as 0 to 1 dw by dx u du by dx of dx plus 0 to 1 w of dx to 0. This is equal to 0. Okay. Then this is the big one which they are asking for in the question. Now we have to check whether we can get the quadratic function as well. For that, W should be equal to delta U. Now, from 0 to 1, d delta U in dx U du by dx plus 0 to 1 W if dx is equal to 0. This is the equation. Now, what if we replace the U in W? If we replace U in W, this is not simple. Uh, So if you say this W and this U, it is inverse, we will get the same equation. Hence, we can't use delta U not equals to 5 U by dx U. And so in that case, kinetic energy is not okay. So we have part D, which is the beam on elastic condition. So we will start solving that. D part. So the equation is given as d2x d2 dx whole square d d2w dx square is kw is equal to 5. Okay, so let's start solving the weak form 0 to 10. So now one more thing, let's calculate the problem. This is small than x if form is w due to calculate. This is wave function d2 dx square b becomes dx square plus k over w minus f. So the this is the result and the solution we are writing with the recipe. Then 0 to w f and w t2 minus dx square v d2 w minus dx square dx plus 0 to l w kw dx minus 0 to l w dx is equal to 1. Okay, when you combine it by doing by points, you will get there, you will get w dy dx d d2w by dx square at 0 l minus 0 to l dw by dx dy dx d d2 by dx square dx. So you have to since you see what things are there in this, you have to use brackets again and then you have to apply the boundary conditions. So I'll write the final equation, applying one more time by parts. What you will get is this. Now we have to discover the solution of the weak one. Now we can check the check with quadratic functional. For that, W should be equal to delta W. This can be capital W should be equal to small w. So let's apply this in the weak form. D2 delta W upon dx square b d2 W by dx square plus 0 to 1 delta W kW dx minus 0 to I delta W f dx is equal to 0. Now let's interchange W with M. So you can see if this W is changed to this W, this W is changed to this W. Everything remains same. You have more time, it will remain same. So for this quantitative function is okay. That's all the things which I have for today. Uh, if we have a specific doubt, someone asked me last time about the symmetric to which student.
Yes, yes, sir.
What was the doubt?
Doubt was actually means there was in the lecture in the last part the
Uh,
faculty was saying that if the linear part sorry the bilinear part say B U W equals to B W U. Okay,
wait,
so in that case the weak form formulations and the strong form formulations will give the same result.
I'll open it. I'll open the lecture. Oops.
If weak form is symmetric bilinear function.
Okay. So it's covered in book four. How this one? This one?
Yes.
What I said?
Yeah, the last part which some flow this potential energy delta 1 of pi equals to 0. This gives us the strong form.
Okay. Yes.
Then the weighted integrals means after doing the pi parts we get the
Uh,
weak form. Then
okay.
this check of symmetric bilinear form.
Uh,
This check I had means I couldn't understand properly. It's how
so
did we?
if this check is not there, na, you can't use this property. Where it is? This property you can't use that. Delta. Okay. In calculation variation.
Mhm.
Property. Because this is there. Can't use the property. Is it? You can't see. This coming from so yes, it will pay for the zero.
Yes, yes.
Although here
This one.
use the this relationship, how updated impact inside in data.
Yeah, this proof only. Can you just
Uh,
explain it once?
So what he is doing, this B That is written like this, like this, like this, and you
Mm-hmm.
get like this. Now, you can get check. You want to do this?
Yes, yes.
You do it up to the time. So there's a property in the uh, this this kind of property what it is. So the property is when you have delta by 2 u square,
Mm.
delta by 2 u square, you can write u delta u. So what you can doing this, you treat it as a differential equation. So if you
Yeah, it
use the
seems like that.
differential, you get 2 into u.
Yes.
And it's not the general differential equation. So that's why
Okay.
you have to use u delta u. And this property is this can really where when it is linear. So now
Okay.
you can get a one picture in this. Same thing as done in this. That
Okay.
if you go opposite, is the CR differential equation. So whenever you have to take on question variable and use a form, you use the same property as the differential you use with a
Okay.
delta.
That's why this half is coming.
This is the same like that way.
Okay.
This is the property of the relation is.
Okay. Okay.
Anyone else? Mhm. With this today's solution, questions, let us see the other assignment. The assignment number 3. The questions are all same related point and you'll surely get the solution in easily with you. Whatever doubts are not there, I try to post it in the Google forum and the next I'll take.
Okay. Thank you.
Thank you.
Thank you. Bye.
Thank you, sir.
Thank you.